All right. So we're on this. Did you guys finish up that? What was it? 3.3. Double angle formulas, half angle formulas. That good? Having any trouble? Get the help you need. Make sure you master that. You know, I'm available 12 to 1 today, and Roberto's got a bunch of hours. Get the help you need. All right, we're in 3.5. We're breaking it into two sections, like the easier part and the hard part. I think we should finish the easier part today and begin the harder part, and then finish the harder part on Monday. Our practice exam is next Wednesday, right? Because I'm pushing from the schedule, I'm pushing it back a day, right? Remember all that? So practice exam number 3 next Wednesday. What is that? Wednesday the 18th, huh? So next Wednesday the 18th will be our practice exam, and then actual exam number 3 will be Monday, the Monday right after that, the 23rd. So this is a 10 here. So that's the plan. So we just got this is the last section to finish up, but we got it in 2 parts. So the easy part today, the hard part Monday, practice exam Wednesday, real exam number 3 Monday. We have 5 exams total, so we're moving on. This is the last week to drop. I've reminded you that a couple times, right? If anybody wants to drop any of your classes, this is the last week if you want a W instead of a letter grade. All right, so let's answer this question. Cosine of x is -1/2. How do you, so we want to find all the x values. We want to find any x value that you could plug in there, and the cosine of that angle would be -1/2. That's what we're looking for, right? When we're solving trig equations, we're trying to find what could x be, what angle, right? Because you put angles into cosines and sines and tangents and things, right? Put angles into trig functions. So what angle, the cosine of what angle is -1/2? And really, which angles? It's more than one angle, huh? There'll be more. There's always going to be more than one answer, more than one place where the cosine is -1/2. How do we find it? How did we find it last time? Unit circle, right? We do everything on the unit circle. So what I'm suggesting you do is go ahead and make a unit circle, and then put the 3 dots in each quadrant. Remember how we have 3 dots, right? One in the middle and one closer to each edge. 3 dots in each quadrant. And basically, I'll give you a hint. 2, I think you already know, 2 of those, excuse me again, 2 of those dots are places where the cosine is -1/2. So you want to look at all those, 12 dots, and ask yourself, which ones have a cosine value that's -1/2? And the 2 thoughts you got to be clear on to track that down is the small, medium, large thing, right? Small, medium, large. The small is 1/2. Medium is √2/2. Large is √3/2, right? So it's 1, 2, 3 over 2. So you look at -1/2 and you go, oh, that's the small. That's the first clear thought you've got to have. It's the small. And the second thought you have to have is cosine the x value or the y value of the dots, of the coordinate points? Cosine is x. So you're saying, I'm looking at all those dots, and I'm asking myself, which dots have an x value that's negative back a small amount? So let me let you think about that. I got to run through. Okay, so as you look at those dots, excuse me, we're trying to say which dots are negative back. Because, when you're talking x, negative is back. If you're talking y, negative is down, isn't it? Because x is right, left. So negative is back, left. So we're saying, so first off, we're only looking at dots over here, aren't we? You with me? We're only looking at negative x values. Because cosine is x, and negative is back. So which of these dots, which of these 6 now, are back just a little bit? This one and this one, huh? You with me? Those 2 dots are back the lowest amount. The ones in the middle are back the medium, and these 2 over here are back the most amount, aren't they? So the two dots I've circled are back the least amount. Okay, so what is that angle? Well, that's just, this is 90, so this is 120, just 30 off of that. This is 270, so this is 240 here. So 120 and 240 are our two locations. We've just got to convert those now into radians, right? They want radians, don't they? Yeah, I was looking at that too, Wendy. I don't see them saying that, but I just assume that's what they usually want. So I'm going to do that. So I'll come up here and give them what they want. So 120 degrees times pi over 180, right? So that's 120 over 180 pi. Cut out the zeros, 12/18 pi. Reduce it, divide by 6, top and bottom. 2/3 pi, so that's one of the answers. 120 is 2/3 pi. 240 is twice as big, isn't it? 240 is just twice 120. So just twice 2 pi over 3 would be 4 pi over 3, wouldn't it? Right, you just double it. So those are the two answers, 2 pi over 3 and 4 pi over 3.
You put the commas separate?
Yeah, exactly. So the way they want the answer right here in this box would be 2 pi over 3 comma 4 pi over 3. Yeah, they want both answers with a comma, no parentheses or anything. It's not like a graphing thing, and the order doesn't matter. Really? Okay, let's go. We're totally right. I got to finish up. They want all answers. Now, what do we mean by all answers? We got to add 2 in pi. Why? I kind of ran out of time last time to make that super clear. So those are the two answers, but both of them plus 2 in pi. Why? Because what they're saying is, and they're going to change this in a little bit. Where do they say it? Fill in. Well, I don't even see. Is it off the screen? Oh, no, right there. Find all. See this word, all solutions. Now, in a minute, maybe 20 minutes or half an hour, they're going to say, just give us all the answers between 0 and 2 pi. They'll change their plan. But for now, for these first, 5 or 6 problems, they're going to say, give me all the answers. So if they say all the answers, they mean all the answers. They don't just mean ones between 0 and 360. They don't mean just ones within one loop. They mean like, what if you go around 1,000,000 times and end up here? That works too, right? And so we have to give them all possible answers no matter how many times you go around this circle. So basically we want to say, you go around the circle as many times as you want and then end up here, it's going to work, right? The cosine will be -1/2 or here, right? So how do we say go around the circle as many times as you want? We add 2 in pi to those, yeah. So the way we do it, and come back up here, is they actually want, 2 pi over 3 plus 2 pi in, 2 in pi. It doesn't matter how you write that. Because what is that? That's a bunch of full circles. N is any integer. Notice n can be 1, 2, 3. N's like a counter. We're saying n can be any integer. Any, like whole number, 1, 2, 3. It also negative. It can be -1, -2, -3. It can be 0. So it can be any, it can't be a decimal. N can be any whole number. Yeah, type an expression using n as the variable. Yeah. So when you write 2 in pi, see, no matter what n is, that's a full circle, right? Because 2 pi is a full circle, so say n is 3. Well, then that's 3 full circles. That's 3 2 pi's. So we're saying, for example, you could go 3 full circles and then 120. Or you can go 4 full circles and then 120. Or any number of full circles and then 120. That's what we're saying, plus 2 in pi. So the answers would be, let me actually write it all out now. The answers would be 2 pi over 3 plus 2 in pi, comma, 4 pi over 3 plus 2 in pi. Do you guys want me to type that in? Does anybody already type that in? I'm pretty confident that's the answer. You typed that in already, Chinu? It takes that. Yeah, so that is what it wants. And the reason is because they said all solutions, not just, in a minute they're going to change it, just solutions between 0 and 360, 0 and 2 pi. Good? Are we good on that so far? This is a challenging section, so I want to be helpful. Let me talk about it. I'm forgetting something. What I'm forgetting is tangent has what's it called? A period of pi, not 2 pi. That's the problem. Let me show you. So back to the now that we're back in action. you know, I just want to throw this thing in the trash. Like, you having some kind of pen problem now? Okay, hold on here. Hopefully, oh, good, we're all happy now. All right, so back to the unit circle. So yeah, so looking at this unit circle here, and the dots. Okay, yeah, so the places, again, where is tangent 0? Where's tangent 0? Tangent is sine over cosine. Let me just say this again so it'll be on the recording. So how do you make sine over cosine 0? You make the numerator 0. You make the top. That's how we make a fraction 0, is make the top of the fraction 0. So we're really saying, where is the sine equal to 0? Where's the sine? Sine is the y value. So which points have a y value 0? This one right here and this one right here. Those two dots have a y value 0. What are they? 0 degrees and 180 degrees, or pi. Okay, now, normally, now for the new part. Normally, we say at this point, okay, get this out of the way. And normally we would say, well, it's those two answers. It's 0 plus 2 in pi, comma, 180, or pi. Let's just make that pi. Pi plus 2 in pi. That would normally be right if this was sine or cosine. So let me write a special note for you over here. So the period of sine and cosine is 2 pi. What is period? How long till it starts repeating itself? How long till it starts repeating yourself? Remember the graph of sine and cosine? Like, let's just do sine. From 0 to 2 pi, and then he just does the same thing again every 2 pi. Remember, he just keeps repeating himself every 2 pi. Remember how sine does that, cosine does as well? So basically, every 2 pi, all the values of sine repeat, and cosine. So that's why for sine and cosine, we always add the 2 in pi for sine and cosine. But for tangent, his period, the period of tangent, is only pi. He repeats himself more quickly. Tangent repeats himself every pi. So that means when you do all answers for tangent, you got to go plus in pi, not 2 in pi. Everybody seeing the difference? So I know some of the subtleties might escape you, but let me just drive this point home. If you're doing sine or cosine, it's plus 2 in pi. If you're doing tangent, it's plus in pi. Because pi repeats himself tangent repeats himself every pi, right? Every 180. If you think, how do we know? We're supposed to know that you are, because remember back when we had the tangent graphs? I know you think, I don't remember all that. I know, that's what's challenging about this class, is keeping it all together. But yeah, every 180, every pi, tangent kept repeating itself. The tangent just repeats all his values every half a circle. So you guys track with me on this. Pi is half a circle, isn't it? 2 pi's all the way around. Pi's halfway around, right? So my point is, tangent repeats all his values every half a circle. Okay, so what does that mean? That means I got to make this plus n pi, get rid of the 2's here, plus n pi, right? 0 plus n pi and pi. I know that's not the final answer, I'm getting there. 0 plus n pi and pi plus n pi. You good? So far. And there's going to be one more simplification if we use a little logic. Do you see what that's saying? You guys tracking with me? You got to have your thinking cap on right now. I hope I'm not doing the wah teacher, Charlie Brown teacher voice. You tracking with me? So what this is saying, what we're saying the answer is we're saying, hey, you can start here at 0, and you can what? Add any half a circle. Because tangent repeats every half a circle. Not every whole circle like sine and cosine, right? It's a period. So if I'm saying you can start at 0, and then you can add any half a circle. Or you can start at 180 and add any half a circle. Well, do you see what's going to happen? If you start at 0 and you add a half a circle, where do you end up? 180. And if you start at 180 and add a half circle, where do you end up? 0. So we're like double talking. It's like saying you can be even, or you can be a number dividing by 2. Or, I'm saying the same thing in 2 different ways. Do you see how I'm saying the same thing? Right? So in other words, the answer is just n pi. It's, you don't need both these. These two are saying the same thing. You can just say it's 0 plus n pi, which is just n pi. Does that make sense? They're saying the same set of points. One more time. So the first answer is saying start at 0 and add any half circles, and add to it as many half circles as you want. Right? If you start at 0, you say you can have 0 or any half circle. So or here, or back to here, or back to here, right? Well, that's the same thing the other one's saying. You say you can start at 180 and add any half circle. Well, that's all the same dots, isn't it? That's all the same locations. So we don't, sometimes they do that. Sometimes they're both saying the same thing, and then we don't say them both. You could say this one, 0 plus n pi, which is just n pi. That's the answer they want? Is that what you guys said? Yeah, they're right. I was messing up. So the difference is tangent repeats every half a circle, sine and cosine every full circle. Is that good? All right. Come see me. I'm glad to help you more with this if it's confusing. All right, let's try this one. So we have 5 sine theta plus 1 is 3 sine theta. And they want us to find all solutions. So again, we're going to have to do the plus 2n pi thing at the end. Okay, so can you first off get the sine alone there? Let me give you a second. Solve for the sine like it's an x. Now, let's pretend it just says 5x plus 1 is 3x. You know, basically treat the whole sine theta like a big x. You know what I mean? And just, you don't have to write an x. I don't mean literally write an x. Just solve for sine theta. So what am I talking about? What do you do when you have like a variable, in this case it's a whole sine theta, on both sides of the equal sign? Yeah, get rid of one of them, huh? Just get rid of them. It doesn't really matter which one, right side, left side, whatever. I'm just going to subtract 5 sine theta. That's going to be a little quicker because then I'll just have the 1. And this will be minus 2 sine theta. Okay so far? 3 sine theta minus 5 sine theta. There's minus 2 sine theta. Good so far. Trying to get the sine theta alone, just like I would an x or something. What do I do next to get the sine theta alone? Divide by the negative 2. Boom. Sine theta is alone. So sine theta is negative 1/2. You guys, okay, I took that negative from the bottom and put it in the front. It's all the same thing, huh? It doesn't matter where the negative is on a fraction. Okay, now can you so now it's unit circle time. So we did that part. Now go to the unit circle. Draw your unit circle. This is the part I want to make sure you're comfortable with. Well, I want you to be comfortable with all of it, but especially, I know this can be tricky. So let me give you just a little bit of time. You get more out of it instead of me just whipping it out. So go ahead. Let me give you 30 seconds, maybe 45. Find out where's the sine of theta negative 1/2. Feel free to compare with those around you. Okay, how you doing? Sine are the y values, right? Sine is the y values. So we look at this and you should think y value negative small amount, right? The small, medium, large thing. We good on that, right? The half, root 2 over 2, root 3 over 2, small, medium, large. So that's the small. And it's negative. So in other words, it's a y. Now y values are up, down, not left, right, huh? It's a y value. It's up, down. So that means it's negative. So that means it's down a small amount. You okay with all that? Which dots among all those 12 dots first off, we're only thinking about these 6 because we're down. We're down. You with me on that? We're talking about dots that have negative y values, aren't we? We're saying the y value is negative. Well, that means it's got to be those. It can't be those top 6. They all have positive y values, huh? It's usually 2 dots. It's almost always 2 dots. So which 2 dots among those 6 have a small negative y value? They're down a small amount. This one and this one, huh? Is this getting more comfortable? Those 2 dots are down a small amount, aren't they? Their y value is small. Their sine, their y value is down a small amount. Is that good on that? You do need to be able to do this like this. Even if I gave you a calculator, even if these were on the calculator part, calculator will not give you both those answers. It only gives you one answer. When you hit sine inverse, you know, it only gives you one answer. So you need to be able to do this. Okay, so what are those 2 spots? Well, this is 0. So this, and it's also 360. So this is 330, right? It's just 30 below 360. Is that good? This is 180 in the middle, so this is what, 210? 30 more than 180. Good on that. So 210 and 330. How many got those 2? How are we doing? Did you get those 2? Okay, that's good. Glad to see a majority. Just want to know whether I should speed up or slow down. Okay, so 210 and 330. So now we just got to convert those to radians and throw on a 2 in pi. We basically got it. Because this is sine, so we'll do a 2 in pi. It's not tangent, where we'll just throw on in pi. So come on up here, get a little room. So I got to convert those to radians. So take the, what is the first one? 210 degrees. Multiply by pi over 180. That's, I'm just going to cut out the zeros. 21/18 pi. Cut out the zeros. Divide by what, 3? That'd be 7/6 pi. So there's the first answer. The other one is 330 times pi over 180. That's 33/18 pi. Divide by 3, divide by 3. 11/6 pi. So there's our 2 answers. We good with all that? And so it's 7/6 pi plus 2 in pi, comma, 11/6 pi plus 2 in. Whoop, what am I doing? Making a fraction. 2 in pi. Is that good? Is that what they took? Well, you probably have a different question a little bit.
Mine was positive y half.
Right, so a little different. We all good on that? All right. So what's different on this one now is they have a 2 theta in there. They're saying cos of 2 theta is negative a half.
We have a constraint.
What are all the solutions in the? Oh, good, good. That's nice. So in other words, when they say 0 to 2 pi, they're saying, well, let me explain it at the end because this one's a little tricky. Yeah. So go ahead. So just do the normal thing. So at first, don't even worry about the 2 theta. Just pretend it's not even there. Just do the normal thing you would do. What's the normal thing you would do? You would draw the unit circle, right? Put the 3 dots in each quadrant. Like that. And see if you can find. So again, don't worry about the 2 theta. Don't do anything different with the 2 theta for now. Just do the regular. That's 2. We're looking for 2 dots again, right? We're looking for 2 dots whose cosine is negative a half. So is cosine x value or y value? X. Cosine is sideways. Sine is up and down. So cosine, so we're saying, where is x equal to negative a half? Is that the small, medium, or large? That's negative the small about. So first off, we're looking for an x value that's negative. So we're talking about this hemisphere, right? It's got to be, because those dots are negative x values, aren't they? Those 6 dots. So it's going to be 2 out of those 6 dots that all have negative x values. And which ones have negative just a little bit? Well, this one and this one. We did this already today, didn't we? Cosine negative half. So same thing was a few minutes ago. So this is a 90. So this must be 120. Oops, it's not working. There we go. 120. And this is 270. So this must be 240. So 120, 240, like that. Got those two so far, so good. Let's turn those 2 spots now into radians. So take the 120. In fact, anyway, let me come on up here actually, because I want to do something else down there. We will do something about 2 theta, but we'll in a minute. So take the 120, convert it to radians. Pi over 180. That's 12/18 pi divided by 6. So 2/3 pi. That's right, we did this 4, and the other one is 4/3 pi, huh? Twice as big. 240 is twice as big as 120. So 2/3 pi and 4/3 pi. So far, so good. Now, what are our 2 overall final answers? Let me write them separately, because now the trick's going to come in. We would say, well, the answers are, and it's not that tricky, but the difference. Anyway, 2/3 pi plus 2 pi n or 2 n pi, however you want to write that. And the other one would be 4/3. Before it's a 3 there. 4/3 pi. I'm getting scribbly there. 4/3 pi plus 2 n pi, like that. Those are the 2 answers. Now, those are the 2 answers, but they're for 2 theta. We did all this work for whatever angles inside of that cosine, whatever's been plugged into the toaster, but that's 2 theta, not theta. You with me? So that's what 2 theta equals. So we just got to divide through by 2. Oh, but there's an extra trick. Yeah, hold on. Let me show you. But everybody good so far? Everybody see why I'm saying 2 theta equals that? Is that making sense so far? That's because that's what our plug is. And normally all the other ones, see, we just had regular theta. Look back here, regular x, or we don't have like double angles. So this is a double angle. So you just do all the same work as normal. And then when you get to the end, you write the 2 theta thing. Now, here's the trick. This is a hard section, so anyway, here's the trick. When you have 2 theta or something like that, 3 theta, whatever, you must let n be 0, 1, 2, ... until you have all answers between 0 and 2 pi. Let me show you what I mean. Remember what that n is representing. It is representing extra full circles, right? Extra full circles. So in other words, we've got to say, okay, in particular, this 2 theta is 2/3 pi plus 0. First off, you let n be 0, it's just 2/3 pi. Comma, 2/3 pi plus 2 pi. If you let n be 1. Am I losing you? And then two-thirds pi plus 4 pi if you let n be 2. See what I'm doing? I'm just taking my formula. They might wonder, well, why are you doing this? We knew this before. We just left it like this. Right, because of the 2 theta. Because of the 2 theta. So when you have 2 theta, you have to do this extra step at the end. 2 theta, 3 theta, any kind of multiplying theta. Instead of just plain theta or plain x in the trig function. You have to do this. You'll see why in a minute. Just hang with me for a second. You'll see. Probably seems kind of weird right now. Because, remember, so and how far do you go? Well, that's actually more than I need. Here, so do a couple of them, and then here's how you find out. Those are all these are equal to what? 2 theta. And we actually, in the end, want theta, right? That's what they're asking for right here. What is theta? Plain theta, not 2 theta. So now it's divide by 2 times. Each of these, divide by 2, divide by this whole thing by 2, divide by 2. You with me? I got to divide, right? Because these are like 3 set. Are you okay if I write it with commas? It's really like 3 separate equations. I just don't want to don't have room to write them all out. You good so far? So they're all what 2 theta equals. Divide by 2, and you'll get what theta equals. Well, how do you divide 2/3 pi by 2? Whoops. Yeah, the easy way is just to stick the 2 in the denominator and it cancels. Because to divide is to be in the denominator. So just do that. Does that make sense? So it's 1/3 pi, or pi over 3. So the first answer is pi over 3. You with me so far? So the first answer is pi over 3. How do you divide the next one? How do you divide the second answer? By 2. Well, this 2 cancels and this 2, both of them. So it's pi over 3 plus pi. Whoops. Good so far? I divided by 2, canceled both those out. Same thing here. Divide by 2. This becomes pi over 3 plus 2 pi. You with me? Everybody see what I'm doing there? I'm dividing each of those 3 answers by 2. And how did I get those answers again? You might be, it's easy to get lost. I know there's a lot of steps happening here. This came from n equals 0. This came from n equals 1. Where? Right here. 0, 1, 2 for n. This came from n equals 2, right? Remember what I did? I took the formula answer, which had an n. This is what you have to do. A lot more work. Sorry. When you have a 2 theta, you got to do this extra work. 2 theta, 3 theta, whatever. And you got to actually, you can't just leave it like that. You got to take that formula and let n be 0, n be 1, n be 2. Write out what you've got, then divide through by the 2. We get to this. Now, remember what it is they actually wanted from me. Only answers between 0 and 2 pi. They don't want extra rotations. They only want final answers between 0 and 2 pi. Well, he's out. And anything beyond him. Because he's more than 2 pi. Isn't he? He's 2 pi plus some more. He's beyond 2 pi, isn't he? And anything after that would also be beyond 2 pi, right? Because as n gets, if that's why I didn't do n equals 3 or n equals 4 or do any more. Because it's only n equals 0 and n equals 1 that gives us valid answers less than 2 pi. You with me? I still have to do the other side also. This is a lot of work. This is why I broke this section into 2 days. So does everybody see that? These are the first 2 valid answers.
Wait, it can't be 2 pi?
Yeah, because they said they only want answers from 0 to 2 pi. Right here. What are the answers in the interval 0 to 2 pi? So they don't want any answers bigger than 2 pi. And see, this is bigger than 2 pi because it's 2 pi plus more stuff. So it's bigger than 2 pi. Yeah. Everybody seeing that? Is that making sense? So this is out because it's bigger than 2 pi. Okay, so we have these 2 answers. Those are good. Now, I've got to get probably 2 answers out of this other piece. Doing all the same steps. Can you do that? Let me give you a second. In other words, do the same stuff I just did. Let n be 0, let n be 1, let n be 2 on that. Guys, I'm sorry, we can't have any talking back there. I'll have to do something next time, okay? Movie or something. Because the other people around you have to be able to hear and focus. All right, so you got to take that formula, let n be 0, let n be 1, let n be 2, and then divide through by 2. Do all that same stuff. See if you can get answers on that. All right, let's try it. So, there's just no more room here. So we'll take that 4/3 pi. So I'm going to take this other formula now. I'm going to let n be 0. First off, that means just 4/3 pi, huh? If you let n, put it up here. If n is 0, then you get just the 4 pi over 3. If you let n be 1, here, if n is 1, then we get 4 pi over 3 plus 2 pi. Remember, these are what 2 theta equal. At first, some of these answers look like they're more than 2 pi, but remember, we're going to divide by 2. That's what brings some of them down within 2 pi. N equals 2 is going to be too much again. Excuse me. Yeah, you don't need to do an equals 2. It's going to be just like the other one. It's going to go too far. So now, take that and divide through by 2, divide by 2, divide by 2. And so what happens? Theta equals 2 goes into 4 2 times, 2 pi over 3, and then comma. The other answer is 2 goes into 4 2 times and cancels that 2, and we get 2 pi over 3 plus pi. The other answer, I didn't do an equals 2 because it would be too much, just like it was for the other one. So there's the other 2 answers. We have 4 answers altogether. We have to actually combine those. I can't leave this like this. I have to put those together. It's going to be 5 pi over 3. Can you tell? Let me finish that for you. So far so good. We have these 4 answers. And this problem just keeps going and going. So finally, this guy is 2 pi over 3 plus, I got to combine those together. The pi, this pi is 3 pi over 3, isn't it? And then I can combine them and I get 5 pi over 3. So that's a 5 pi over 3. This is really 5 pi over 3. Everybody okay with that?
How's that pi? 3 pi over 3.
What's 3 over 3?
Oh, right.
Is that good? 3 over 3 is 1. This is just a fancy 1 pi or pi. That's just a way to write pi with common denominator, right? We all good on that? Does that make sense? And same thing down here. This one down here, pi over 3 plus pi. I've got to combine those together as well. Let me do it down here. And what am I going to do with that plain pi again? Same thing. Make it 3 pi over 3. And this is 1 pi. Number 9, cosine 4x, negative root 3 over 2. So give it a go. I want you to do most of the work, get more out of it. So start with your unit circle, right? Draw your unit circle. Find the places where the cosine is negative root 3 over 2. Feel free to help each other out. Feel free to talk and help each other out in these times when you're trying problems. Finding the dots you need. So cosine is cosine x values or y values? X values, right? And they're saying, and then the root 3 over 2 is at the small, medium, or large? Yeah, minus the large, right? And so first off, we're only talking about this hemisphere, because we're talking about dots that have negative, x values that are negative, right? You with me? Dots that have x values negative, and which two dots, it's almost always two dots, have a large negative value? This one and this one, huh? Those two dots are back the most, aren't they? The most negative large value. Good there? So there's your two dots. Find their degrees. This is 180, so this must be 150 and 210. So 150 and 210 are our two angles. So take the 150 and 210, turn them into radians. Pi over 180, 15/18 pi, divided by 3, 5/6 pi for that first one. And then the other one is 210, which is 21/18 pi, divided by 3, top and bottom, 7/6 pi. We good? So we got those two answers. Good so far. And now, because they gave me 4. Now I want to be helpful and clear on this. If they had just said cosine regular x, instead of 4x, if they just said regulars, I'd be done right now. If they just say that, I don't even have to do the 2n pi thing. If this is just regular x and they only want answers between 0 and 2 pi, done. But if they say they want all answers, then you got to go the plus 2n pi thing. If they want all answers. Everybody seen the difference? There's 3 style of questions they will ask you. They will say, give me all answers. If they say all answers, you got to do the 2n pi thing, or for tangent, n pi, right? If they say they want, if they say the angle is something other than x, like 4x or 2x or 3x, then you also have to do the 2n pi thing, because you have to find the other spots where it can do it. You have to also do it for that reason. If they do neither of those, if they just make this regular x and they don't ask for all answers, they just want answers between 0 and 2 pi, then you don't have to do the 2n pi thing. I'll write that out in a minute. In a minute, I'll write all that out when we have one that doesn't require that. Anyway, for now, you got to do the 2n pi thing again. So now this time it's going to be a lot, guys. It's not just going to be n equals 0 and 1. I think n equals 2 and 3 will also work, because you're going to divide by 4 in the end, which means a lot of values will work. I don't know if you're getting the hang of how this works, because that makes things small, dividing by 4. So a lot of extra rotations are going to be included. Well, you'll see. Just start cranking them out. So take 5/6 pi and 7/6 pi. You guys tracking with me? Let me continue number 9 here. So you take 5 pi over 6 plus 2n pi. Down here, what was the other one? 7? Yeah, 7/6 pi. 7 pi over 6 plus 2n pi. Remember how to do this? So you take those two answers now, and what do? You come up top, and you let n be 0. That's just 5 pi over 6. This one's just 7 pi over 6. Then you let n be 1. Then you let n be 2. Then you let n be 3. Sorry, this is very tedious. I feel a need to apologize for this math. This is very tedious. They're not going to give us a lot of these double angle, triple angle. These are pretty painful. 5 power 6 plus, what's 4? Plus 8 pi, and this is going to be n equals 4, 7 pi over 6 plus 8 pi. Okay, yeah, right there, guys, I know I need to go no further. Do you know how I know that? Because what are these all equal to? All equal to 4x, huh? All this is the plug into the cosine function, which is, so what? Well, that means 4x equals all these different categories, and 4x equals all these, or let me move it out of the way down here. 4x equals all these different categories. Okay, so what? Well, that means I'm going to divide through by 4, because I want regular x. So I'm going to divide by 4 in this denominator. 4, 4, 4, 4, 4, 4, 4, 4, right there. Look at that. What's that? What's 8 pi over 4 going to be?
2 pi.
2 pi plus some stuff. That's too much. That's more than 2 pi in the end. You see that? That's the one that's too far. See, when the extra added piece, this is 2 pi, well then this whole 2 pi plus extra stuff is more than 2 pi. That's beyond a full circle. So that's where I don't need the n equals 4. Same thing here, right? I'm going to divide through by 4. So in every denominator you put 4. And right here, see what that is? 2 pi. So again, n equals 4 is not needed. So you just keep going until one of the pieces is 2 pi. So the whole thing is more than 2 pi. That's when you're beyond where you need to go. You're supposed to find all the answers up to 2 pi. That's what they asked us to find. Everybody see how I did that? Because we're dividing by 4, we have to go further. See what I mean now? How I knew it was going to go further. All right, now you just got to simplify all them ugly little fractions. Unfortunately, it's super tedious. So what do we got? 5/24 pi. That's an answer. What do we got here? 5/24. Yeah, they're all going to be 5/24 pi at first. Plus, now what's that? Well, you got to get a common denominator. Am I racing ahead of you? You guys okay to there? Everybody see what we're doing? It's okay. It takes hours of practice in this. It really does to get all this down. Now, if I want to add 5/24 pi, add something here. I've got to get a common denominator, don't I? You with me? So I've got to multiply this by 6 to make the why? Because that'll make it 12 pi over 24, and then I can add them to be 17 pi over 24. See what I did there? You got to get a common denominator to add those. You got to make the bottom 24. Is that good? Is that awful? All right, now this one, same thing. It's going to be, see how they're all 5 pi over 24 at first. So I got to make that other denominator, right? See where I'm at? I'm working on n equals 2 at the top. I got to make that other denominator 25. I don't want to cancel those 4. You might think, why don't we just cancel those 4s? No, that's not my goal. My goal is to make common denominator, not just simplify. So what do you got to do to that 4 to make the bottom become 24? 6 again, huh? So this will be 24 pi over 24. Add those up, 29 pi over 24. And that's okay, just leave the top bigger like that, that's fine. These are our various answers. We're getting our final answers now. Finally. And do that last one. Well, it's not the last yet. 5 pi over 24 again. Plus. All right. Get a common denominator here again. With that 6 pi over 4, you got to make the bottom 24. So to make that bottom 24, multiply top and bottom by 6. 36 pi over 24. Add that up. What is that? 36 and 5. 41 pi over 24. So there's the 4 answers for the top. We're halfway there. Now we need the 4 answers for the bottoms. Everybody see how I found those? Questions I can answer?
Is that going to be in the no calculator test portion? Or is it the whole test?
Yeah, they could be. Yeah. Yeah, there's nothing we've done that really requires a calculator. It's a little painful without a calculator. Okay, and then coming on down to this next part. I haven't made the test yet, so I don't exactly know. So 7 pi over 24, that's the first answer here. These are all going to be 7 pi over 24 plus, and then same thing, you got to get common denominator. So multiply top and bottom by 6. 12 pi over 24. That's going to be what? 19 pi over 24. Next one. 7 pi over 24. And multiply by 6. 24 pi over 24. Add those up. 31 pi over 24. One more. And this is, again, 7 pi over 24 plus, multiply top and bottom by 6. And 36 pi over 24, add them up. 43 pi over 24. There we go. Yeah, Ajane.
How come we crossed off the n equals 4 row?
You're like, how come I crossed these off? Or I'm sorry, I'm not listening very well. Sorry. This, yeah, good. Because when I divided through by the 4 here, you see how this piece right here became 2 pi, and then the plus whatever 2 pi plus some more means this is higher than 2 pi, and we can't have no answers higher than 2 pi. Yeah, that's how we know when we're done. Everybody, it's a really good question. Everybody seeing that? That's how I knew I was done there, and I didn't need to go n equals 5, n equals 6, and keep on going. Like, how do you know when to stop? As soon as you start getting final answers after the division, after the dividing by 4, that come out higher than 2 pi. That's how you know. All these other 4 answers here and 4 answers there are below 2 pi. They're valid answers. You got to type all. It's a pain just to type them in. You got to type in all 8 of those answers, separated by commas. That's why I broke the section into 2 days. Is that good on that? Awful, but okay now. Makes sense how to crank through those? Hardest thing in the course, I think, is this section. All right, I'm going to move on if you're okay. It'll be on you. Okay, so tangent 3x is 1. This is number 10. I'm just going to write it fresh here. So tangent, so we have more room. Tangent 3x is 1. So you know what to do, right? I know this is going to be easier. Some couple nice things will happen. And by the way, it's tangent. So what does that mean? We're not going to add 2 in pi. What are we going to add? Just in pi, right? Yeah, it's just tangent has a half a circle repeating cycle. It repeats itself every half a circle, just pi, not 2 pi, right? All right, so go to it. Yeah, this will be easier, I think. Yeah. The first step's a little tricky. Yeah. So draw the unit circle. See if you can find where tangent is 1. That'll be a valuable exercise. Feel free to help each other out on that. Let me give you a minute on that. All right, where is the tangent 1? Well, what do we always do for tangent? Sine of cosine. I'm not even going to think about 3x right now. Just forget about that. Remember, we do all that later. So I'm just thinking, okay, tangent, sine over cosine, right? That's what we always do for tangent, sine over cosine. So where is the sine over cosine 1? That's weird. How do you have the sine of cosine 1? Think with me. Think with me, everybody, for a minute. What if I said, hey, guys and gals, I've got a fraction, I got a number over a number, and it's coming out 1. What does that mean? How can you have a number over a number equaling what? They're the same, right? The only way you can have something over something coming out 1 is if those somethings are the same, right? Like 7 over 7 or 3 over 3 or whatever. They got to be the same, don't they? If it's equaling 1. So that's what you need to think right away. You need to think, oh, you're telling me sine and cosine are the same? So you're asking me where are sine and cosine equal? The same. Yeah, where do they equal? Right there, 45 degrees, the medium, because it's medium and medium. You guys with me? Because sine and cosine are both, the over and the up are both the same. In the middle, it's medium, medium. They're the same, but there's always 2 answers. Remember, almost always 2 answers. Where's the other answer where they're exactly equal? Good job. Right here, because they're both negative. We can't go here because one's positive, one's negative. We can't go there because one's positive, one's negative. You guys tracking with me? Let me say that again more slowly. Remember you know what you could do is just all students take calculus. That'd be the easiest way. All students take calculus. Right? We're looking for tangent to be positive 1. Where's tangent positive? First quadrant, they're all positive in the first quadrant, and third quadrant, tangent's positive. It's got to be first and third, doesn't it? And that's because in the third, remember the sine is up and down and the cosine's right and left. So this is a point that is back root 2 over 2 down root 2 over 2, isn't it? You don't need to write that, but that's what it is, huh? It's back medium, down medium. See, they're both equal, they're both negative. And this point, they're both positive. The other two, like this place, one's right, the other's down. One's positive, the other's negative. So they're reverse signs. So they're not equal. They're negative of each other. Yeah. So it's those 2 spots here and here. And that's 45. What's this? Well, this one is 180 plus 45, isn't it? 180 plus 45, 225. So this is 225. We good? 45 past 180? Is that good? So we got our 2 answers, 45 and 225. 2 places where tangent is 1. Now convert those to radians and then set up the 3x thing and the 2 n pi. And, the 2 pi, the n pi. because it's tangent, so we don't use 2 pi, we use regular pi within. All right, so we've got, what do we got? We've got 3x is equal to, oh, we got to convert them first, huh? 45 degrees times pi over 180. It's 45 over 180 pi. Divide by like 9. That'll be 5/20th pi, which is pi over 4. And take the 225 times pi over 180. 225 over 180 pi. Reduce that thing. I don't know what goes in there. Divide by something. 5, I don't know. 5? 5? I need a calculator. 36 and 200 would be 40. Is it 45? And then divide by 9. Pi is still here. 5/4 pi. There we go. 5/4 pi. That'd be hard to do without a calculator. So 5/4 pi. So we got pi over 4 and 5 pi over 4. You know the pi can be in the front or in the top. It's all the same thing, huh? Right? You good with that? If I wrote 5 pi over 4, that's the same. Right? Because to be alone is to be over 1. Same thing as being the top, right? All right. So anyway, so those are 2 answers. Now take those 2 answers and do the plus n pi, huh? Not 2 n pi. So take those 2 answers now and do the n equals 0, n equals 1, n equals 2, n equals 3. You're going to need to go a ways here probably because you're going to divide by 3. I don't know how far exactly. Probably quite a ways. Oh, but anything bigger than pi starts to repeat. Yeah. Right, Don, is that true? Yeah, but we want all answers between 0 and 2 pi, don't we? What did they ask for? We have to give them all answers between 0 and 2 pi. So take those 2 answers, pi over 4 and 5 pi over 4. And let's go to the next screen. This is number 10. So take pi over 4 plus n pi and pi over 4, no, 5 pi over 4 plus n pi. We good? Take our 2 answers, pi over 4 and 5 pi over 4, plus n pi, not 2n pi, because it's a tangent, not sine or cosine. Right? And then start cranking through your values. N equals 0. Pi over 4. N equals 1. Pi over 4 plus pi. N equals 2. Pi over 4 plus 2 pi. N equals 3. Pi over 4 plus 3 pi. N equals 4. Pi over 4 plus 4 pi. Oh, wow, that's going to keep going and going. This is a terrible problem. N equals 5.
6, I believe.
Is it? Plus 5 pi.
Or 6
Any-
is the highest.
Pi over 4 plus 6 pi. Oh yeah, 6 won't work because we're going to divide by 3, right? Remember what it was? This is 3x. Remember from the beginning this has been 3x? So 3x. So you're going to divide through all these answers by 3, and when you put 3 in the denominator, every denominator, right here, see that? This piece is 2 pi, so forget about it. That's beyond 2 pi. See how n equals 6 goes beyond 2 pi when I divide through by the 3. So yeah, we got to go up to 5 on this. That's terrible. That's as bad as I've seen. 0 up through 5 on that. And you got to combine all those together. I'm going to do this one down here. So n equals 0. 5 pi equals 4. N equals 1. 5 pi over 4 plus pi. N equals 2. 5 pi over 4 plus 2 pi. N equals 3. 5 pi over 4 plus 3 pi. N equals 4. 5 pi over 4 plus 4 pi. N equals 5. 5 pi over 4 plus 5 pi. And that's as far as we need to go. Now we got to do the common denominator. We got to divide. I forgot to divide on this one. So this is 3x equals. So divide by 3. 3 in every denominator. And then what do we got? So putting that all together, we got a big mess. Pi over 12, there's one answer. This is pi over 12, let's squeeze it up here. Pi over 12 plus pi over 3. But we got to get a common denominator there, don't we? So that means, are you with me? Am I just working by myself up here? Multiply by 4, you guys already done? 4 top and bottom. 4 pi over 12, what is that? 5 pi over 12? On that one? That okay? You guys tired of these? I'm a little tired of these. This isn't thrilling me. I mean, I enjoy math, but not so much. This is getting a little tedious now. This is not so enjoyable.
At the end, would it be like 10 answers total, right?
Well, remember, it's 0 through 5. So that's 6 and 6, 12 answers. Remember, it starts at 0. So 0 through 5, so it's 6 answers and 6 answers, 12 answers. 12 answers, separated by commas. Yeah. Right? You guys want me to do more? I mean, pi over 12. And this, yeah. Yeah. So I'm going to go dot, dot, dot. Is that okay? You just keep cranking them out. In fact, there's probably a pattern here. That's usually the case. You can see a pattern. Let me see. What would this one be? Multiply top and bottom by, whoops, don't erase it. By 4. It'd be 8 pi over 12. So it'd be 9 pi over 12. Yeah, it's adding 4 every time. Yeah. Normally, guys, as soon as you see the pattern, just track it. Right? So we got 1 pi over 12, 5 pi over 12, 9. See, it's adding 4 to the top. So next one would be 13 pi over 12. Yeah, it always follows a pattern. Add 4, 17 pi over 12. Add 4, 21 pi. Yeah, once you get the pattern, just boom, just track it. So it's just adding 4 to the top every time. And down here, this is going to be, first one will be 5 pi over 12. Then it's going to be the same pattern. It's going to add 4 again. So it's going to be 9. Oh, no, it's not going to add 4. I don't know what's going to do, but I better do one. So top and bottom by 4 here. By 4, what's that going to be? 5 pi over 12 plus 4 pi over 2. Yeah, that is it. Oh, that repeats. 9 pi over 12. That's the same answer. These are going to be the same answer. Oh, yeah, because it's the half a circle away. Is that true? Oh, yeah, how dumb this was of me. Yeah, I didn't need to do all these. They're half a circle away. It's going to repeat every half circle. It's a waste of time. See how these answers are all going to come out the same? 9 pi over 4, 13 pi over 12, 17 pi over 12, 21 pi over 12. Right? These are all the same. Add 4 here. Wait a minute, is that right?
But they repeat twice. It's, I think 13 pi over 12, that'll be 13 pi over 12. That'll be 17, 17, or something like that.
Yeah, so it started at 5. Add 4, add 4, add 4, add 4, add 4. All these are repeat, aren't they? Repeat. All those are repeats of the answers above. Except for 25 pi over 12, which is an invalid answer. Why?
pi.
It's more than 2 pi. 25 is more than 2 times 12. Right? 24 pi would be 2 pi. This is more than that. We got beyond 2 pi here. Now you think, well, how did we do that? Well, these are just not easy. It's because that was almost 2 pi, and then we added some more.
It's only for,
So none of these matter. So it's just 6 answers in the end.
it's only for tangent, right? You don't,
Right, exactly. So really, guys, if I was being a little sharper today, I would have remembered that I didn't need to do the 225 at all because it's tangent. Because tangent repeats every half a circle. You see what I'm talking about? So I didn't need to go a half a circle away and deal with all those answers. Now, sine or cosine, you do. Because sine or cosine only repeats itself every whole circle, full circle. But tangent repeats every half circle, so you don't need to do all those values. They're already going to be repeated. As we saw when we did all the work, they were already here, and these were just repeats. So really, this is all you needed to do.
Oh, so
Go ahead.
so that's
Chip.
why you did n pi. I was gonna ask why you did n pi.
Yeah, that's because of tangent. Exactly. Yeah, so for tangent, well, yeah, does everybody see why I did n pi this time instead of 2 n pi? It's because of tangent. Tangent repeats every pi. If you do sine or cosine like back here, we had to do 2 n pi for sines and cosines because they repeat every 2 pi. Every full circle, they repeat themselves. But tangent repeats itself every pi, every half a circle. So you always use n pi for tangent.
Do some reducing.
What's that?
Maybe we need to reduce some of those numbers. You got 9 pi over.
Oh, you're right. Just that one, huh? Oh, and the 21? Yeah, so you have to reduce, yeah, sorry. So, boy, this problem will never go away. You're right. So let me erase this. So final answers, 2 of them need to be reduced. You're right. So we have pi over 12, 5 pi over 12, 9 pi over 12 needs to be reduced. Divide top and bottom by 3, and it's 3 pi over 4. And then the next one, add 4, 13 pi over 12, that's good. Add 4, 17 pi over 12, that's good. Add 4, 21 pi over 12, no, that needs to be reduced. Divide by 3, top and bottom, 7 pi over 4. There we go. All the circled ones are the 6 answers. Rudy.
Is it the same thing for cotan as well? Because I got a problem with that cotan.
Cotan?
Yeah, same
Yeah.
as tan, right?
Yeah, cotan's just upside down tan. So same thing, the cycle is every pi. Yep, cotan, same as tan. Exactly. Right. Let's do this one. So it's cosine of theta over 2 is -1. Let me just rewrite it. So number 11, cosine theta over 2 is -1. All right, so as soon as we see that the argument is to plug into the toaster is not just a plain theta, we know what we have to do. Well, first off, unit circle, huh? So unit circle, let me give you a minute to do that. Think about the dots. I don't usually write them in, but there's also the dots straight up, straight down, straight right, straight left are also there. So find out where is the cosine. Forget about the theta over 2. We'll do that later. Just, hey, where is cosine? -1. Let me give you 30 seconds. So you need to be able to come up with that. I'm glad to help if you're having trouble. Cosine -1. So is cosine x value or y value? So you're saying, where is x negative? Which dots? First off, we're only talking about dots over here. Because cosine is negative, right? All these dots have negative x values, don't they? So which one of those dots is a full -1? This one only. At this time, we only have one answer, rare. Usually it's 2. That's the only dot up there. Remember, that's a unit circle, radius 1 circle. All those other numbers, the half, the root 2 over 2, root 3, those are all below 1. You know, if you did your calculus, this is 0.5, this is 0.707, this is point something, I don't know, 86 or something like that. Anyway, they're all below 1. Do you know that small, medium, large are all below 1? They're all less than 1. So when they give -1, that's extreme. That's as far as you can go left. That's this spot right here. Right? Right? What's the coordinates of this dot? Back 1 up 0. Isn't that point back 1 up 0? Isn't his cosine -1 and his sine 0? So who has a cosine -1? This dot right here. 180 degrees or pi radians. So that's nice. We only have one answer. We don't have two. So the answer is only pi. But you got to go pi plus 2n pi, because it is cosine. Cosine, sine, you got to do 2n pi. All right, so let's crank that out. Let's let n be 0, n be 1, n be 2. I think that's about all we'll need. If we let it be 0, you just get pi. Let it be 1, you get pi plus 2 pi. Oh yeah, we're not even going to go further than that. Let me show you. Let me just stop right there. And what equals this now? Am I going too fast? So I'm just taking the answer pi, which we got from the unit circle, pi, and going plus 2n pi, because it's cosine. Cosine and sine, you always go plus 2n pi. Tangent, you just go n pi, or cotan. Right? Okay. Now you let n be 0, n be 1. If n is 0, this is just pi. If n is 1, it's pi plus 2 pi. And now, what am I going to do with this?
Multiply by 2.
I'm going to, yeah. And by the way, maybe it's easier just to make this pi, 3 pi. This would be pi plus 4 pi, right? If we let n be 2. 5. Maybe you should combine those first. Maybe I'm not doing it the easiest way with y'all. Maybe we should add those first and then do the dividing or multiplying. Yeah, that's probably easier, huh? Sorry if I'm messing you up. Yeah, that might be easier. Yeah. Anyway, yeah, now let's finish it up. So how do we finish it up? What equals this? Well, theta over 2. Right? That's when you finally bring in the fact that the plug-in wasn't just theta. It's theta over 2. Now, if theta over 2 equals pi or 3 pi or 5 pi or whatever, how do you solve that? How do you solve for theta there? Multiply by 2. Huh. Multiply by 2. So I'm going to take that and go times 2, actually. Times 2, times 2, times 2. So theta will equal 2 pi, or 6 pi, or 10 pi. Well, no. Right? All those are 2 pi or beyond, aren't they? All those answers are 2 pi or beyond. So, no solution that's between 0 and 2 pi. They only want 0 up to, see how it's bracketed 0, 2 pi is a parenthesis, so it's not including the 2 pi. Do y'all see that? Because, why do they do that? Well, because they've already got this spot at 0, so they go all the way around and they say they're not going to put 2 pi right on the money. They've already included that spot with 0. Right? That's why they put a parenthesis at 2 pi. So 2 pi is not allowed. So going back over here, 2 pi is not allowed, nor any of the others. So yeah, no solution in the end. No solution after all that work.
What happened if we have 2 beta?
2 what?
2 beta over, like, 5.
Is that what you have in yours?
Yeah.
You have 2. So yours is 2 beta over 5. Mm-hmm. Yeah, good question. Here, let me go back. Let me answer that question. What if right at the end? What do you got? Pi, 3 pi, 5 pi. What if right at the end you have like pi, 3 pi, 5 pi, and instead of what did I have? Theta over 2. Mm-hmm. It was, what did you say? 2/5?
Yeah, 2 over 5.
2 over 5. Yeah, 2 over 5 equal that. Yeah, good. Some of the other versions will be like something like that. What if I had 2 theta over 5 equal all that stuff? Well, then you have to turn it into theta. So what can you multiply by here that'll make it into plain theta? 5 over 2. You just do the upside down of whatever's there. It'll cancel the 5, it'll cancel. And that means you go to every one of these items and go 5 over 2, 5 over 2, 5 over 2. You got to do the same thing all the way. Good question. Make sense? You do whatever it takes to make it plain theta. So I had theta over 2, so I multiplied by 2 over 1, really, right? Which just got rid of the 2. So whatever it takes, so then this would be 5 pi over 2, and you'd get different answers. If those were all over 2 pi as well, there'd be no solution. Woo, that was a lot of work. Now we got 5 minutes. We got